Kia ora, and welcome to this quick overview of using the discharge lamp simulation from PhET. Now, if you have a look at this simulation, we're going to use the configurable one, and we're going to just have the two energy levels. Now, if I just fire an electron, notice what happens when it hits the atom. And I'll just do it again so you can see that the electron gained energy and then it dropped back down to the first energy level and gave off some energy. So you'll see that the wavelength is quite short, which means it's quite a high energy wavelength, and that is also because there's a bigger distance between the two energy levels, so there's a lot of energy and therefore it's a shorter wavelength. If I drag this closer, so I can stop that, and if I drag this closer, then notice what happens when I now fire electrons. Can you see that the wavelength has got longer? And if I look at the spectrometer, notice where this long wavelength is. It is now in the section where it is in the far end of the visible and into the infrared. Whereas if I stop this and I move this to the top and I play it again, can you see the higher energy is down at the bottom in the UV? So I can now include another energy level, and if I move this further down, notice how we have got three different energy levels, so three different ways the electrons can move, from the third to first, second to first, or from the third to second. And if I stop this and reset, then you will notice there are my three wavelengths, and notice each change in energy level when it moves from one to the other, I only get a single wavelength. So I've got three different ways, so I only get three wavelengths. So the shortest distance will be in the visible, and my third to first and my third to second, because they're quite far apart, are quite high energy down here. So you can have a play with that, add another energy level, move those around, see what happens if you change where the energy levels are. Now let's go to the multiple, and what we're going to do here is look what happens to the spectrometer for hydrogen. And notice we've got quite a range there. Also see, although hydrogen's only got one electron, it's got a number of different energy levels that hydrogen electrons can go to. Compare mercury. Mercury has a different layout, and because it's got a different number of protons and different number of electrons, and therefore that'll all influence how they attract each other and therefore the energy involved. And you can see that mercury has got a sort of a bluish whitish light. So if you think of your lights, your fluorescent lights, they use mercury for that. If I use sodium, those are often used in street lamps, and again you can see the change in energy levels. They're not to spectrum, but you can see those two distinct ones there and quite a few in the infrared. So that's why your street lamps are quite yellow, because of those two distinct lines. And if you think of your neon lights that are used to light up your Coca-Cola and so on, and you can see that they are, you've got quite one down in the far UV, very high energy, which is the one that falls down, but the ones that play around up here where they are close together are all around in the red, green, orange. So play around with this, or if you can't use Java, then watch this video and then you can answer the questions in the worksheet. Goodbye.